In this video lesson, we're going to evaluate trig functions without the use of a calculator, instead relying on the idea of reference angles to help us out. So my first thought that I need to share with you is this. Earlier in one of our lessons, we found that when I find the sine and cosine and tangent of an angle that's not necessarily in a right triangle, sometimes I get negative values. Here our sine and theta happen to be negative 2 root 5 over 5. Cosine was also negative, cosecant, secant negative, but tangent and cotangent happen to be positive. Now, there's a reason that these four were negative and these two were positive, and that's based on the quadrant in which our terminal side exists. So, we've got a chart given to us here that outlines which of the trig functions are positive or negative in each of the four quadrants of the coordinate plane. Now, while this may be a lot to look at and memorize, I've got a pretty simple way of helping you remember this. At least I think it's pretty simple. And that would be using these big letters. So starting in my first quadrant and counting around 1, 2, 3, 4, we have A, S, T, C. And our little device to remember this is all seniors too cool. Seniors usually appreciate us using that. You can come up with your own if you prefer, but all seniors too cool is the way that we often talk about it in class. So, all seniors too cool, ASTC stands for, what this is telling us is it's telling us which of the trig functions are positive in each of the four quadrants. So the A stands for all, as in all of my trig functions are positive in the first quadrant. Doesn't matter. S stands for sine, as in sine and its reciprocal cosecant are the positive ones in the second quadrant. The T stands for tangent. In the third quadrant, tangent and its reciprocals are the positive trig values. And finally, C in the fourth quadrant stands for cosine, because cosine and its reciprocals secant happen to be positive in the fourth quadrant. Now, why is it that they're positive and negative in those particular quadrants? Well, I want you to think about what are the values of points that are in the first quadrant. Well, every point in the first quadrant has a positive x value and a positive y value. Positive, positive. In the second quadrant, my x values are negative because I had to go to the left. So I have a negative x value, but I went up, so I have a positive y value. And remember, sine is equal to the y value, which happens to be positive, over the r value. R, being a distance, is always positive. Tangent in the third quadrant. Well, points in the third quadrant happen to be negative x's and negative y's. And if sine, which is the y value, is negative, and cosine, which is the x value, are both negative, remember tangent is equal to sine divided by cosine, so negative divided by negative is going to be positive. But the other two are going to be negative. So in the last quadrant we've got cosine. Well, x values are positive because I went to the right. Y values are negative because I went down from the origin. So that means that cosine, which matches with the x value, is going to be positive, and anything that has a y value in it, like sine or tangent, is going to be negative in that case. So all seniors too cool, all sine, tangent, cosine, that's how we remember which is which. Now, how do I use reference angles to evaluate functions without a calculator? Well, the sine of negative 225 degrees, it might be something that I could type into my calculator, but maybe I would end up getting an ugly decimal that nobody wants. I want to be able to find an exact value. Here's how I go about doing this. The steps are outlined for us here. Step 1, find the reference angle. Step 2, evaluate the trig function for that reference angle. And step 3, determine the sign of the trig function based on the quadrant in which it lies. So here we go. We're going to first find a reference angle. It's theta prime in this case. Well, oftentimes, again, a little sketch will help. I'll draw just a quick little sketch of what I think negative 225 degrees looks like. Negative means this way, 225 ends up like so. It's a little bit past 180, kind of halfway between 180 and 270 would be. So there's my original angle. My reference angle is the acute angle formed by the terminal side and the x-axis. Well, 225 minus 180, that's 45 degrees. So my next step then, and again, well, another thing I'm going to jot down is that I ended up in this second quadrant. Okay, so 45 degrees. Second quadrant, those are things that I need to write down or remember. So the next thing I do then is I'm going to evaluate the trig function for theta prime, meaning I'm going to evaluate the sine of 45 degrees, which is easy to do because I've got the hand trick that helps me out here. So the sine of 45 degrees, when we count 0, 1, 2, 3, 4, well, 2 is right here, that's 45 degrees. So sine of 45 must be the square root of 2 over 2. Now, the only thing I have to figure out yet is this value going to be positive or negative? Well, since my terminal side was in the second quadrant, and I'm working with sine, I remember that sine is positive in the second quadrant, which means that my value must be indeed positive, square root of 2 over 2. There we go. Now, if I want to check my work, which is always a good thing to do, I could probably use my calculator to help me out. So, since I'm working in degrees, I'm going to first make sure my calculator is in degree mode. And then what I'm going to do is I'm going to evaluate the sine of the original, which is negative 225 degrees. When I hit enter, here's that goofy looking decimal. I don't want that, nobody wants it for an answer. We want an exact radical expression. Now how can I check my work? Well, the way I can check my work is type in the radical and see if you get the same thing. So one thing to note, this is positive, which is good because I said I was supposed to get a positive number. So I'm going to just check. What if I were to take the square root of 2 divided by 2? Is that really the decimal that matches up with it? Sure enough, we did it correctly. Without the use of a calculator, just using the calculator to check. Try another one here. Now in radian measurement, and we got cotangent, which is kind of a tricky one. So, cotangent of 5/3. Again, remember the steps? Step 1, find a reference angle. Draw a little sketch. Boy, 5/3 pi. 5/3, that's kind of close to 6/3, and 6/3 would be 2, so it's probably fairly close to being a full 2 pi. It probably comes around here and stops. I bet that's about 5/3 pi. Now, my reference angle was right here. So my reference angle is going to equal what's left? Well, 6/3 would be all the way around, and I came up a little bit short. 1/3 short, in fact. So 1/3 pi will be my reference angle. Quadrant, I'm in the fourth quadrant. That's an important thing to remember as we continue to move on here. So then, I evaluate the cotangent of 1/3 pi. Oh boy. This is not something that's quite as easy to do with the hand trick. But I'm going to think through a couple things here. First of all, 1/3 pi. 1/3 pi is, let me see, a third of 180, so that's 60 degrees. Okay, so as I use my hand trick here, I'm going to think about 60 degrees. Again, these are just thoughts that are in my head. So, cotangent is also a thing that I remember. Cotangent is equal to cosine over sine. Because remember, tangent is sine over cosine, and cotangent is the reciprocal of that. So cosine over sine. So here's what what I'm thinking. I'm using my hand, again, no calculator. I need to find the cosine of 60 degrees. And the sine of 60 degrees. Well, cosine of 60. When I do cosine, I start with my 0 up here. I go 0, 1, okay. So that means cosine of 60 is going to be 1/2. When I do the sine of 60, I got to count from down here. 0, 1, 2, 3. Okay, so sine of 60 is going to be the square root of 3 over 2. Fraction divided by fraction, multiplied by the reciprocal. I'm going to end up with 2's canceling. That's going to be 1 over the square root of 3, which will simplify into the square root of 3 over 3. So, cotangent of 1/3 pi is the square root of 3 over 3. Last thing I need to check out, remember, now that I got the right value, is, okay, I'm in quadrant 4, and I'm working with cotangent. In quadrant 4, cosine is the positive one, which means cotangent, the reciprocal of tangent, must be negative. So I need to then put a negative sign in front of my answer. Negative square root of 3 over 3. There we go. Now how do I check that one on my calculator? Well, I'll show you. I need to take the cotangent. Now, cotangent is not one of the buttons on your calculator, but tangent is. So, if I'm going to have the reciprocal of tangent, here's how this works. I'm going to take 1 divided by the tangent of 5 pi divided by 3, 5/3 pi, close parentheses. Now, before I hit enter, I'm now working in radians. I better change my calculator to radian mode. And then quit takes me back to the main screen. So I'm ready to go. 1 divided by the tangent of 5/3 pi. I hit enter. I get negative 0.57735. Again, an ugly decimal, but what was our answer? We said negative square root of 3 over 3. So let's check that. Let's take the opposite of the square root of 3 divided by 3, We hit enter, we get the exact same decimal, which means that we did this problem correctly. We'll do one more example. The cosecant of 7/6 pi. Again, working through our process here, we draw a little picture to figure out what the reference angle is. 7/6 is a little bit more than 6/6, so it's a little bit more than 1. Say something like that. Which means our reference angle is just a little bit past 1. Well, how far past 1 did I go? About 1/6 of pi. And this happens to be in the third quadrant, work with cosecant. Okay, so now I evaluate the cosecant of 1/6 pi. Let's see here, 1/6 pi, 1/6, the sixth of 180, that's 30 degrees. So again, in my head, without my calculator, I'm thinking about it this way. I'm thinking about the fact that I've got 30 degrees, and cosecant is the reciprocal of sine. So I'm going to figure out in my head, what's the sine of 30 degrees or 1/6 of pi? Well, 0, 1, okay, it's going to be 1/2. The reciprocal of 1/2, remember, because cosecant is the reciprocal of sine, reciprocal of 1/2 is going to be 2. So cosecant of 1/6 pi must be 2. Now, last thing to check is the sine of my trig value. So I'm in the third quadrant. In the third quadrant, well, seniors, 2, cool, T is for tangent. So tangent and cotangent are the positive ones. Everything else, like cosecant, must be negative. -2 is what we're going to end up with. Now, to check this out in the calculator, one more example here. We've got cosecant of 7/6 pi. Again, cosecant is not an expression or a function that's on my calculator. Sine is, however. So we're going to take the reciprocal. We're going to take 1 divided by the sine of 7/6 of pi. Oops, close the parentheses here. I'm in radian mode from the last problem. I hit enter. I get -2. No need to figure that out. -2 is -2. That is what the answer that I need. So that's using reference angles and our hand trick to evaluate trig functions without a calculator.